Well, welcome, people. We're just going to give it a few minutes as people join us. I can see the numbers going up here. Great. That is nice to have you on. If our pre-session is anything to go by, I think we're going to have some fun today.
Good.
So, looking snazzy in your Hawaiian shirt.
I got a dress for success for the webinar here.
Yeah, well,
TechCast, I should say. Yeah.
Yeah, I must compliment you on your hairstyle, by the way.
You get the little elephant things on the top. That's what my girls, they got great. Dad, you got the elephant hairs on the top. You can probably see.
Yeah, the little wispy ones. Yeah. No, they get attacked. Right. Let's see. We're getting a few people. We'll just give it a few more minutes.
Yeah, we're good.
Yeah.
Let's see.
All right. And then I'll make a start shortly.
Okay.
All right.
I reckon. Let me see. Get the list here.
So Carrie's working her magic in the chat.
Really? Yeah, I think I recognize some.
Yeah.
Some names here. Lev. Come on, you're awesome.
All righty. Well, I think we'll make a start. If you can share your screen, sir, and give us the first couple of slides.
Oh, okay. So I will share that, and I'll bring it back to the beginning, the official beginning. Yes. How about that?
Perfect. So so welcome everybody. My name is Roger Cressy, and I'm from a company called Mindshift USA. I'm the principal and founder of that company. And but more to the point, I actually work with a gang of people to present these TechCasts, and our organization is Analytics and Data Oracle User Community. You'll find us at AnDOUC.org. If you can go to the next slide, sir. At the end of this, in fact, you'll see posted into the chat, our wonderful Carrie is going to post these links for you, so you can actually click on them directly from the Zoom. Those will be in the chat from then. Next slide, sir. These TechCasts, just so you're aware, are open to everybody who's got something interesting to say about Oracle technology or is doing interesting things with technology. And like today's story, we're basically going from data to downpours. We're learning how to forecast the weather from Uncle Craig. So, but if you look on the TechCast page, and you can see it up on the screen now, you'll see a lot of really good content out there from some very clever people. And we would love to have abstracts from you if there's something you've got to present and would like to share with us. Please do submit an abstract and we'll evaluate that and grab you for a session. Next, we've got some merchandise. If we go to the next slide, sir.
Yeah.
This is just a bit of fun. Obviously, our organization's a completely volunteer organization, and we use our funds to run these TechCasts and to pay for summits, which we are now doing. Our in-person summit, which is coming up, there'll be a slide about that just now. But these, there's actually some interesting, innovative gifts here, rather than just the usual stuff. We have our own little beastie that Dr. Abby Giles Haig created for us. So please do go and visit and buy. All right, next slide, sir. There's lots of ways to connect with us. We really want to grow a community. This is a place where you can come to get answers, especially if you're on Slack. It's really worth going in and having a look. You'll see that the links are being posted into the chat by Carrie as we speak. But do join us. We can, there's lots of people, including Oracle Product Management, involved in our Slack. But all of these media are useful places to come and get information if you need it. And if we could get people, like Craig to join Slack, you might even get answers for free for things that you might need to find out. Next slide, sir. So this is what I was mentioning earlier. We have our in-person summit coming up March 19th to 21st next year. There's nothing that quite matches meeting in person. We have a very focused few days with lots of learning, and we have Oracle Product Management around with easy access. So it's apart from that, it's just good fun to spend some time in person. So really in a very short while, just one more sort of bit of housekeeping. That is, if you've got a question, please put it in the Q&A area. Do not put it in the chat. I'll be monitoring the Q&A, and we'll try and keep them to the end. If there's anything that materially looks like it should be answered straight away, I will bother you, Craig. But let me introduce Craig without further ado. Craig Shallahamer. I hope I pronounced that correctly. So he's a highly respected figure in the field of machine learning and Oracle database performance tuning. And he's got an amazing amount of experience in building and teaching predictive modeling techniques, including creating a reinforcement machine learning bot in 1990. So he's been doing this a while, which is why his hairstyle looks like mine. So in addition to his work as an applied AI scientist at Viscosity and the founder of Orapub, by the way, you should go and look at that. He's got a couple of well-regarded books, and you should have a look at those titles. We'll post these presentations up on the archive, so you'll be able to go and get all these details later. He's an Oracle ACE director, and he participates in Oracle user groups, sitting on boards and volunteering and presenting like he's doing today for us. But there are some additional interesting things that I always try to find a fun fact out about people. And Craig is someone you should get to know. You will either have a really enjoyable time drinking his gin with him, or be poisoned by the 190 proof alcohol that's involved. But with that, I'll leave Craig to talk to you more about that, and he's going to present to us on data to downpours, where he's going to explain how we can predict for 6 hours ahead of time. Thank you, Craig, for joining us today. Very grateful.
All right, so you want me to go with the chat? Okay. So
yeah, you give a little bit.
This is really interesting. So I started making, I started with the copper still that was really scary looking and was highly dangerous. And then I upgraded to like a stainless steel skill. But then it took the entire afternoon of a day to go through the distilling. So I discovered I can actually just buy the neutral spirits, and I just add my own like botanicals. And I was thinking, I live in Oregon, and you can buy like anything. All right, good for you or not in Oregon. So I thought, I wonder if I can get something on Amazon. So I went on Amazon, and you look right there, I actually bought like ethanol, and I did a double check on ChatGPT just to make sure this was the drinkable stuff, right? When I got it, and it was a gallon. And so when I got this is what it looked like. Okay? It came like in literally a 1 gallon thing. And if you look close, right, I can see it says 190 proof. So this is like more pure than the stuff I could get out of my still. And I just put some of it in an empty bottle right here, and you can see, and it smells just like you would think it would, yeah. But you don't drink it, right? You know that. I actually was, yeah. So I'll actually check this out, because I thought, well, then, why water it down, go through all that trouble when you just drink it, kind of thing. And so this is a couple of years ago. So I said, well, why do I need to water down my my gin or whiskey or whatever. And it said, basically it said, because you're going to destroy your esophagus. I'm like, okay, that's it. All I need is one short answer for that.
Not
So,
worth doing. Yeah.
yeah, so that's a lot of fun, actually. I get a kick out of that. Now, one of my daughters is experiments too. I don't know if I want to give her any of that stuff, but anyways. So the other thing is, this is, since nobody could appreciate as much as you guys, the group listening here, but what I did is I created this conversation. I call it the Shane, the Surfer Oracle Performance and Internals AI Assistant. Okay. So you actually link this from my website, and then you put your email in. And this thing, Shane knows like everything I've ever done in the Oracle community, and anything performance and internals related that has to do with viscosity, which is my employer. And Shane knows all of that stuff. And so, but it was kind of boring. So I said, well, I want to give Shane a personality. So I just made him the classic server, stereotypical surfer. And I added some other stuff, but I made sure that really his purpose in life is to help people learn how to optimize Oracle systems. And you can see, I mean, he's just going for it here, right? I says, hey, let's ride, And I said, hey, I want to learn about bitmap indexes. Can you help me, Shane? He says, hey, dude, absolutely. And he just goes on, and a lot of times he'll have a little surfer lingo in there, but at the bottom, usually he does add a little bit. Yeah, I hope that gives you a good overview of Oracle bitmap indexes, dude. Let me know if you have any more questions. And I can just say, hey, thanks, Shane. And my keyboard just went. Oh, thanks, Shane. And see what he says here. Hopefully he doesn't have a mind blow up right here when it's live. But I wrote this. This is in Streamlit. Python's in the background. So yeah, you're welcome, dude. I'm stoked to help you out. So it's just, you can have a lot of fun with this stuff. It's good little proof of concepts and all that. So, all right, that's a little bit about me. Should we get into the real stuff?
Yeah, please, let's carry on. Sorry for the distraction, but
this is actually,
a bit of fun makes the world go round. All right.
Who likes to listen to this stuff? It only takes this kind of group of people that are even, are curious about how this stuff works too. Yeah. Okay, so my name is Craig Shallahamer, Oracle ACE Director. I'm the Applied AI Scientist for Viscosity. I'm a co-founder of OraPub. My wife and business partner is the other founder. But that's why I say co-founder. So today we're going to talk about how to do rain prediction. And I wanted to make this kind of personal. So there's actually like a driving story behind this. But one of the things I wanted to do was I wanted to use only Oracle technology for this. So we're going to use a bunch of Oracle tech, Autonomous Database, OML for SQL, REST APIs. I think those are the key part. Oh, and the whole OML, infrastructure, the notebooks and all that kind of stuff. There's no Python involved. It actually would have been much easier if I just did the whole thing back in Python, because I'm not a PL SQL programmer anymore. So that made it a little trickier. But so let me get into it real quick. You heard a little bit about me. I've been doing Oracle since 1989 is actually when I started. But I used to have a bunch of slides about kind of my little machine learning journey, because most people know me because of my forecasting and Oracle performance tuning background. Right. But I actually, in 1990, I think this was in C, I distinctly remember I created a learning tic-tac-toe program. And I thought, man, it actually worked, and it got better as I played it. But then I thought it's taken forever to learn. So I said, well, if I create another one and they play each other, maybe they'll learn really fast. And they did. I'm like, and then I could play it. And I'm like, wow, this thing is actually really good. So that was in 1990. And so, I've always had this love for creating things that learn to get better and that I can interact with. And, over the years, and that's kind of gone down. And now it's just gone to a whole nother level right now. So that's why I love all the chatbot type stuff and the conversational and just all the reinforcement learning. So that was my reinforcement learning project before. I don't think that term even existed back then. So Roger said, I got a couple books. This is the same book. Don't buy both of them. They're the same title. In 2007. And right now, from a official class perspective, I have a couple machine learning classes. I break them up into two. First one's anomaly detection and then performance prediction. It's all Python based. It's done in the Colab environment. I write all the code, so you don't have to be a Python person to actually do this. So if you're interested in that, check it out. I start the machine learning one, I think is in November is when I'm going to have the next one in that series. So just so you know a little bit about my deployment background, right? It's interesting when people say, well, so what have you actually deployed? All right. I've done, a lot of people don't know this, but I've done a bunch of internet marketing stuff over the years. And one of the projects that I did was to get the hot leads for a very specific promotion. And I used machine learning for this, and it was weird how well that actually worked. So that was like, wow, this stuff actually works. I don't know if you ever get in that situation that you talk about it, you think, but does it really work? And it was like, wow, it worked really good. And then IT operations probably isn't a surprise if you guys know my background, anomaly detection and performance prediction. And then I've done quite a bit of work now, what I could do in the time. Domain specific, QA bots and conversational assistants. And I always like to put a personality on that. And I've worked in a couple different areas on that, like the Oracle performance area. That's what I just showed you. Biblical text, you can put any ancient text. You can actually ask the AI questions that you've always wanted to ask. And it's amazing the response that you actually get back. And then there's a company that does real estate investing. Done some work with them in this area as well. So that's about Chain. I worked for Viscosity. They acquired Orapub a couple years ago. Just fantastic people. I knew about them years ago because they started moving people into the Oracle Cloud when it had just started. So it was pretty dicey back then. So I worked with a bunch of great people. You probably heard some of these guys at conferences before, and there's just a plethora, a ton of books. How about that? Okay, so let's get ready for the main show here. All right, so I like to hike. Okay, hiking is one of the big things in my life I do, especially in the summer. And so weather is actually really, really important to me. Now, I live on the Oregon coast, so it rains. And I got this is actually like legit. It rains and it gets cold sometimes. Okay? And it rains like a lot. And so what I wanted to do was to create an app that would actually forecast rain. And you might think, well, Craig, you can just go to Weather Underground. No, it's not good enough. So I'm going to show you how I actually built this out. Okay, the output's not fancy, but this is coming from a REST API, and this thing is live right now. So if you actually wanted to, do the phone thing or copy and paste, the bit.ly link right here, this will give you a forecast in Tillamook County, Oregon, which is where I live. Tillamook cheese, that's the place, and that'll give you a forecast. And I'll tell you about what this output actually means coming up. But that's the end game. Okay. So here's let me back up, and here's the situation, okay? It's helpful for me if I know it's going to rain, okay? Especially on more local hikes that I want to know if it's going to rain 6 hours into the future. So I live in the Pacific Northwest, so, it rains a lot. So it's not like a desert situation here. So most of the hikes, I'm going to go out and get back within 6 hours, okay? So I want a 6-hour rain forecast, okay? So, but have you heard of a 6-hour rain forecast? And that's local. No, they don't get that. You can look ahead, but it doesn't really answer the question. Within the next 6 hours, from now, 6 hours, is there going to be any measurable rain? And when you have a local forecast, if you're actually looking closely, and you guys are like AI people, that it's really not that local. And sometimes the AI is really not that good. So I thought I could actually do better. So I wanted to do this in all Oracle technology. So I wanted to build an AI. It's going to forecast the likelihood of rain now out 6 hours into the future. And I wanted this thing to run just from a URL. I didn't want any security. I didn't want to log on. I just want to refresh the screen, boom, and I want the answer. And it works weirdly well. So I'm going to show you how I built that. And I'm going to end with some of the honest kind of challenges I had doing this with all Oracle tech, because I didn't want to go outside of that. I wanted to use all Oracle. So the first thing I needed to do was to get data, and I need to get a bunch of it. And 10,000 rows is what I ended up with, which actually worked fine. I didn't actually need more of that, although more would probably be better. So, where do you get weather data? Well, everybody says, well, Craig, go to the NOAA website, and I said, no, it's not that easy. I needed just some basic weather information, and like in my part of the world. And it was not easy. And the files, the data you get, if you do get some data you can download, they're a mess. I mean, they're really bad. And there's this weird stuff, and it's not labeled well. It's just really difficult. So after way too much time, I actually stumbled upon aviation weather. And I don't know how to pronounce the system, whether it's METAR, but it's METAR. And many, at least airports in the US, they upload their weather station data to the system. And a lot of local airports do this as well, which means you get really local weather information. And usually they upload around every 20 minutes, which is just, which is fantastic. So that's the data that I used. Now, it's easy to get the data too. It just takes a non-secure, HTTP call, and I can get up to 30 days worth of historical data from a particular weather station. Well, 30 days at 20 minutes each is not a whole lot of data for me, right? It's not much. And I'm not going to do the math in my head right now. So what I did is I also grabbed the weather station data from surrounding airports in the Pacific Northwest. And so that allowed me over like probably 2 or 3 months of getting the data, I ended up with, these 10,000 rows. So it actually worked pretty good. But the data, as you'll see, is still kind of messed up. And I'll tell you about some of those challenges. So I used the Oracle, the Oracle machine learning, I'll say, environment framework ecosystem. So what that means is under it all, there's the autonomous database that's actually running. And then I'm using OML. So I'm going to use the OML notebooks for this. I'm going to use the OML jobs facility. And I'm going to use OML for SQL. So everything I'm writing, all the code is in SQL or PL SQL. I didn't cheat. I didn't do any Python at all. Okay. So what I did, I used 3 notebooks for this. Okay. The first one was to load and to pre-process the data. So I kind of on demand when I need some like new data kind of a thing and get it all, all formatted, transformed, right? That's what that first notebook is all about. Oh, and you see the P2, the P2 stands for Project 2. I'm writing a book on OML for SQL, which I put on the shelf for a while, as you'll find out later why. And so this is Project 2. That's what the P2 is for. So it's not a part 2. It's kind of wacky. So you load and pre-process the data, and then the second notebook, this is where I'm going to build the machine learning model, and I'm going to evaluate it. So I'll spend a few minutes on the evaluation also, because there's there's a ton of different ways to evaluate, and I love the evaluation portion because it's like a whole rabbit trail on its own. And then I needed to make a decision about how I wanted to deploy this. Right? And as you'll learn, I would probably do it different next time if I had to do this all over again. But it actually technically works really well. And so there's another notebook that actually runs, it's relatively short, and it runs top to bottom. And that's actually how you test it to see if it'll deploy. You just say run all the cells, and if it works, you get a forecast at the bottom, then everything is actually good. Okay? So I'm using notebooks for this. Now, how the forecast is done, every 20 minutes, the deployment notebook is automatically run in the OML jobs facility. It basically sits on top of DBMS jobs. Okay, and so I have it scheduled to run every 20 minutes. So the notebook needs to run unattended, top to bottom. So that's actually a really good test, because if you can do that manually, when you actually put it in the jobs facility, it actually works really well. It's like it just works. Okay. So this will run every 20 minutes, regardless of if I want a forecast or not. In fact, it's running every 20 minutes right now. Okay. And that's good and bad. So how do I actually, get that REST API? Well, I did all that through Oracle as well. with Oracle as well. Now, I've never, created a REST API in my life before this project. So it was actually very intimidating because of the steps to go through. But once I went through it, I'm like, this is super easy, right? And you get a URL at the end, which is what you do to get your forecast, and you just put in your SQL statement right here, and it just works. So in the job, in that deployment notebook, when the job is run every 20 minutes, it puts a row in this weather prediction results table, and the REST API grabs that. Okay, and so I can just show you, like, it's hopefully this is always sketchy live demo here, but I'm just going to refresh this, and there we go. I don't know if you noticed, but the time. Okay, this is the weather station. That's for Tillamook, airport and Oregon coast, and that's Pacific US time right there. The prediction result is 0. It's not going to rain. Okay. The other beauty of this is you get the probability of this. And it's like, Craig, there's no way it's going to rain, man. Okay. No measurable rain in the next 6 hours. So and this is being called from that REST API. Okay, so let's get into it a little deeper here. And yeah, you can do this. I'll keep this running for like another day, but then I'm gonna stop the autonomous database. And when you stop the autonomous database, not terminate it, just stop it, everything else kind of stops as well. The jobs stop, the REST API, and so there's like no charge. The meter stops running when you do that, which is nice. Okay, so I'm going to go through. I got it good. I'm doing pretty good on time. Presentation was built to be quite a bit longer. So let's go through the OML notebooks. Okay, the first one, and I'm not actually going to give you live, like demos of it. These are all screenshots, but these are the working notebooks, and you can download those off my website too. I have all the notebooks. I have everything for you if you wanted to go down that path. So the first one, data collection and pre-processing. But the first thing I'm going to do is to create like the master table, and that's where the good data ends up, that the models are built from, all that kind of stuff. So I just, create that. And then I'm going to need to load some of the raw weather station data for the airports. And so all I need is just the airport code, which is like this 5-character kind of a, thing. And then it's just going to grab it from the system, regardless of where it is in the US. Now, I haven't tried this outside of the US. I'm sure you could do something different. Well, my original intent was to use personal weather stations. That's what I wanted to do, because I love weather stuff. But then I didn't want to give I didn't want to have everybody hammering on my API or my weather station. I didn't know if that would end well for me. So anyway, so I'm going to load some raw data. And it's a CSV file, but this data has like this header portion, which has all this stuff in it. And then you get to the actual like rows of data. So it's not that simple. If you look at the code, which I'm not going to show you, I had to use some Apex stuff so I could call outside of the autonomous database environment outside on like a non-secure URL to actually get the data in. It was not fun, but some Apex folks to Viscosity kind of led me in the right direction. They actually really helped me out there. So once I load the data, I'm going to look at the data, explore it, and then I'm going to show you a little bit of this. And then I had to impute some missing data values, which is really interesting. Then do some feature engineering, which is like, I love feature engineering. That's the gold. And then I had to label the rows. This is a classification problem here. So I don't have any details on the labeling, because it just gets, let me just explain it to you. The labeling was a little tricky, because the question I'm trying to answer is it going to rain from now 6 hours into the future? So if you let's say this is a row of weather station data, old stuff, current, and then like new stuff. Okay, so if this is my training data, then I'm going to have the label right here, and I need to know, okay, well, this is going to be a 0 if there's no rain, or 1 if there is, if it actually did rain. This is my actual historic data. I'm creating the label. So for this to be a 1, I have to look through the data and 6 hours into the future. Remember, there's like 20-minute weather station data samples probably. I have to look ahead 6 hours, and if there's any measurable rain in any one of those, this label is a 1. Otherwise, it's a 0. So it's just kind of this, thing that goes like that. so, and this is all done in PL SQL. Can you imagine like looping through all that? God, it was a freaking nightmare for me to do that, but it works, and it works really good, and it's super fast. So that's how it actually did the labeling. And then once I'm sure that the data is good, I'm going to merge that into the master data table, so I can then move on to the second notebook to actually create the model. So just a couple things I want to mention was that the pre-processing was actually significant, and it was difficult for me to actually do. And I have everybody's got their issues. I have issues with people that just skip the pre-processing. It's like you go to the guy to buy a car, 0 down, easy payments. That's what it feels like. And if he asks, well, where'd you get the data? Oh, I got this CSV file. And I just give that to the algorithm. No, it's like never like that, unless you're just like learning and you got a really nice, CSV file or something. So it's not like that. So it's a fair question, and speakers hate this, and teachers, and you say, well, was the data already pre-processed? And the answer better be no. And if they say yes, well, I'd like to know about it, because really that's a lot of the trick. And this whole thing is getting the data pre-processed. Also, when people are talking about AutoML, it really irks me when they say, I just get the data and AutoML just goes. I'm like, really? So anyway, so that's my thing. But in my case, I did have some pre-processing that I needed to do. Okay, so I'm just going to show you one little piece that I had to do. So here's actually in an OML notebook, I've loaded some data. It's in my weather pre-process table right here. Okay. And if you look at this, you'll notice there's like some empty cells right here. Okay. Now, you might be surprised by this. I certainly was. When I looked at some other weather station data and they had like just empty values, well, it meant something different than what it is for this data, for the airport data. Well, in another set of data, you see that's like, that's the wind gust in knots, and this is the precipitation in inches, okay, or like the last 20 minutes, something like that, right? Or I think it is. Yes, that's, I'm pretty sure. So the question is, well, what is that empty value? Is that a 0? Well, I thought so, but if I looked at some other data, if it was empty, that means it hasn't changed. So an empty value here, hopefully you can see my screen here, that means that the wind gust is still 17 knots, 17 knots again, 17 knots. Oh, now it's 18. Now it's 18 knots again. Now it's 18 knots again. Now it's actually 38. Yeah. So you would have to impute the values for that, do some kind of looping stuff. It was a pain. But what it turns out with the airport data, an empty value means 0. Okay. So there was no wind. And on the precipitation, if it's blank, that just means there's no rain. It's a 0. No measurable rain is the way to actually say that. Okay. And it was probably like that for most of these others as well. But that's just one example of the stuff that I had to do to actually, clean up the data a little bit. But other than that, once I actually figured out what the columns were, which wasn't immediately obvious to me, which one's dew point, which one's temperature, that kind of thing. But once I actually figured that out, it wasn't that bad. So it turns out, because if the wind speed knots is null, that's what that's going to equate to within Oracle, then I just update the table and the wind speed is 0. So it works really fast, really easy. What's interesting for me is that the process of figuring that out and then how to actually set it to 0, that's what took me a while. Okay, once I'm like, well, yeah, I just do an update statement, and if it's null, set it to 0. Okay, the statement's super simple in itself, but getting to that point, it took me a while to figure that out by actually looking at the data and figure out the best SQL to do that. I didn't want to loop. I'd rather use the set operations within, the relational Oracle database to actually do this for me, and it worked just, fantastic. All right, so how are we doing on time? All right, doing okay. All right, feature engineering. Oh, I don't have the top of the hour. I really have like 15, 20 minutes. That's right. Okay, feature engineering. The arrow points to the goal. For me, feature engineering is not only fun, but it's actually where I find like the best features. And I love like moving averages. Here I did like the summation of the precipitation. Taking the value to some power, like some fractional power, seems to be one of the most amazing features when I'm dealing with time series data, Oracle data that I deal with, and just, and probably the data here as well. But I just wanted to get something that just had a few features. Turns out the best features were actually the engineered ones here as well. So I engineered, a bunch of features, not not what you would actually think. I didn't do like, hundreds or actually thousands. So and I'll talk more about that coming up. So once the data was actually really, I felt it was clean and everything, all the counts and everything was fine, then I merged it back into that master table. And so when I train the model, this is like my data source. So as soon as I actually have that, I actually export that, get it out of the autonomous database, and you can actually download my master table in a CSV file, which means you can just load that thing right in if you actually wanted just to skip all this loading stuff and just play with the rest of it. Okay. All right. So build the model and do the evaluation. Okay, here's the steps, and this is all done in the second notebook. So the first notebook was really, just get the data and get it in a usable format that I actually could probably just give it to the algorithm. All right, that's kind of what my goal of notebook 1. Notebook 2, I actually wanted to build like the model and then evaluate that. Okay, so I'm super paranoid with the data. So even though I know I just created the data, I did some verification to make sure the data is legit and all that kind of stuff. Okay, and then I'm going to create an actual training data view. One of the things that is really nice with doing this in OML for SQL is you have your main data set, but it's really easy just to say, well, this segment or these random rows is going to be, like my training data or my test data slash, or my validation data. It's really easy to do with views. And I love that because I don't have to have a copy of the data, which is, really nice. Now, I don't have that much data, but it's just nice to be able to do that. I feel like I have a lot of control. I'm not wasting space and burning up extra memory and CPU. All right, so then I'm going to determine the best features, and I used a feature importance algorithm for that from Oracle. I'll actually show you that. And then I created my training in my testing views. So and I'll talk a little bit more about the evaluation. I did a 70-30 split, and I just randomly grabbed the rows. That's how I actually did this. Now, it is time series data, but all the time series info has been embedded into each row individually. So I could completely scramble the rows, and it's still going to be okay. Right. So I didn't have an issue with that, which actually made it nice. Didn't have to deal with that. So I could just rerun this over and over and over again if I wanted to. There is no in OML for SQL, there is no like k-fold, stratified cross-validation function, their procedure. There's nothing like that. And I was going to create it. And I'm just like, you know what? I just need to get this thing done and move on. So I didn't actually do that. So I just randomly did a 70-30 split, which actually turned out really good for me. I decided to use like a neural network, all right, the multi-layer perceptron for the actual the algorithm to produce the model. And that actually worked really, really well. The reason I wanted to do that is because people talk about those all the time now with all the large language models, and most people don't even know what that is. And so I thought, well, that's why I'm going to use it. And it worked. Yeah, it worked really well, actually. It was just surprising. And then I did an evaluation, which I will talk about coming up. And I used a confusion matrix is what I used, which is what I usually use. That's my big thing, is the confusion matrix. So the training data. All right. So I just created a view. Now for OML for SQL, it's important that I have something to identify each row, and they call it the primary key. And so I just called it primary key, made it real obvious right here. Now, the algorithm is not going to use this, but it wants me to be able to identify uniquely each row that I give it. And so it needs a primary key. That's one of the inputs to the actual function. And on the bottom here, I have the label. I just called it label, but you can call it whatever you want, but it's a classification problem. So I am going to need an actual label in there as well. Okay, so that's all my weather observations. And I did that. That's coming from a view. Okay, I created a view, and it's based on the weather observations all table. All right. So it's super, super simple to do. Okay, determine the best feature. So Oracle actually has a feature importance. They got some algorithms. They got a bunch of algorithms. I'll tell you, it was super frustrating for me. This was one of the areas, and I'll explain that at the very end. I'm gonna group all my frustrations to the very end right here. Okay. But so what I did though, after you just run that process, it puts the results in a view right here. This DM, or it could be a table. I don't know. DM_V. You can see it right there. And here's the chart, and it's kind of nice in the OML for SQL in the notebook, in the just OML notebooks. The charting's they got some nice charting right there. So you can see there's 1, 2, 3, 4, 5 features would seem to be like the best for this particular data set. And then the 6th one is kind of okay, and then it drops right here. So if I was actually going to do this, like for real, I would probably try just the first 3 features and see how that evaluates, then do 5, and then do 6. What I actually did, I did 6, and then I did all the features. That's what I just compared. That's what I'm actually going to show you. Okay, why 6? This is kind of interesting, and I have a point to this. This 6th feature, I personally believed was useful, but perhaps not on the data that I had. What I mean is I had mostly winter and spring data, but I thought it might be very useful in the summer months and the fall. And so I don't really know that, but I thought, well, maybe it is. And so I said, I'm just going to leave it in there. And so that's where I came up with the 6th. So again, AutoML is great, but can AutoML do that? But I don't even know if I'm right either, but that's the human element right there. So multi-layer perceptron algorithm, create the model. If you're not familiar, so I'll just do this like a 1-minute thing here. Okay, this is an artificial neural network. It's made up of little neurons, which kind of mimic a neuron in our body. Got a bunch of them in our brains, right? But they're in like our stomach and other cells, the other areas of our body, I guess. Pretty cool. Anyways, we model them at a series of layers. Okay, so actually I'm going to go left to right on my perspective so I don't mess this up. So you have multiple layers. Okay, there's always an input layer. So data, information, think energy goes into that initial input layer. You can have a number of optional, and you can change the size of hidden layers. And then there's an output layer. Now, we're having a classification problem, and I only need 1 neuron for the output because it's either going to be a 0 or a 1. So Oracle makes it really easy for me to actually, describe like the architecture of the neural network. And it's super simple. Oh, the other reason I wanted to use a neural network is because of all the weights, right? Before the energy makes it into a neuron, right, it actually is multiplied energy by a weight. Okay, sometimes called a parameter. And it doesn't take very long to see all these lines, right, have a weight, except for the biases. But, you see all these weights. And I like telling people about this because you read all about, there's a 7 billion parameter large learning model. Like, well, what does that even mean, parameter kind of thing? Well, it's the weights, at least in part. And so that gives people the idea of like, wow, that's a lot of parameters. Yeah, it is. Okay, so that's why I do that. So it's super easy to actually create this right here. You can see it says where the red arrow on the right is pointing to that's the number of hidden layers. And these are the neurons, they call the nodes per hidden layer. So I have an input layer, okay? And then I have 16, 32, and then another 16 layer, and then there's going to be the output. So that's how you actually define the architecture. It's super straightforward. I'm telling it it's a classification problem, and then that's the data source is my view. And you'll notice there's the primary key in the label right there. It expects that. Okay. All right. So that's how I architected this thing. Okay. Let's move on here real quick. Okay. Confusion matrix. I love these things. I don't like model accuracy. I deal with a lot of rare event data sets, imbalanced data sets, and they're just completely worthless and very misleading. So I don't want to go down that path today. But this is gold to me. I find every project I work on, the confusion matrix, I discover, if I don't already know, what people really care about. Okay, and as I go through this, you're going to learn what I actually care about. Okay, so it happened 195 times up here. The model said, Craig, it's going to rain. So I bring my rain gear, but it doesn't rain. So I'm like, well, I'm kind of irritated, but really I didn't get rained on, so I'm okay with that. okay? And then the model said, Craig, it's not going to rain, and it doesn't actually rain, and it did really good on that, 1,400 times. This is from the test data. This is what really irritates the crud out of me. The model says, Craig, don't bring your rain gear. It's not going to rain, but it actually, I get rained on. I'm pissed. I'm ticked. All right. So for me, if I look at all of this, this is the number that I really care about. So when I compare the all feature model with the 6 feature model, all right, I comparing the 308 to the 368. Now, is it really better, the all feature? Well, I guess technically, but I'm going to run this a bunch of times and all that. But really, is it that make that much of a difference? Don't know. They were pretty good. Okay. I think I'm using, actually, I don't know what I'm using in the forecast. I forget. Anyway, so that's what I really care about. So in my forecasting class in the predictive analysis, we spend a bunch of time on this because it's how I tell stuff's actually working, right? Okay, deployment, real quick. Deployment, you got to create, if the model does not exist, I recreate the neural network model, but I use all of the data, not just the training data. I want all of it, not 70%. So I do that. I don't do any evaluations on it, but there is a kind of a trick here. Because I have moving averages and summations going back like a day's worth of data, I can't just get the most recent like weather station data point. I have to get like a whole day's worth of data so I can do a bunch of pre-processing to get that row all set and acceptable by the model. And then, of course, I can give it to the model. Okay. So when the forecast is made, I'll show you the forecast. This is what it looks like. The select statement right here actually does the forecast. Yeah, it's pretty cool. So see the prediction clause right there. Okay. That's my model that I created to deploy. And you see it's got an asterisk. The asterisk means all of the rows in my view right here in the from clause. If I don't want to use all of the columns in the view, then I have to list them right here. That's why views are so nice. I just define it to be exactly what I need, and my code's a lot cleaner. The other beautiful thing about this, I get a prediction probability. And in my case, I've noticed that if the probability drops below like 0.8, 80%, then the model's like, well, it's probably not going to rain, but it's basically saying you might want to bring the rain jacket just in case, Craig. So I've learned that it needs to be like in the 90s before it's really sure what the heck's going on. So this forecast from the select statement is inserted into a table, okay? And then the REST API is actually going to run something pretty much like this select statement at the bottom. That's going to make the prediction. So if I run this notebook top down and I get the most recent, and I get a forecast, that tells me that the notebook's good. I can put it in the jobs facility and this thing, and then I can schedule it to run every 20 minutes. And the jobs facility is super, super good. Okay, it runs the SQL statement, boom, you get it like you saw. Okay, and then I can get my weather station data. So I want to end. I'll do this real quick. I know we're like almost kind of out of time, but you guys need to know that this was really difficult for me, super difficult for me. So here's my recommendations and things you need to know. Now, this is taken from last June, is the last time I actually touched with OML. So I'm sure stuff's better. Okay. So, okay, I would use SQL Developer as much as possible. Don't do stuff in Notebook, do it in SQL Developer, and then put it in the notebooks if that's what you need to do. It's fast, stable, it just works. Okay. It works really good, and it's super fast. Okay. There's essentially no OML online community. I felt like I was on like a desert island. Okay, super difficult for me. The documentation, there's a ton of documentation, but for me, it felt more like a functional specification. It's very light on examples. The way I learn is a few lines of code that I can literally copy and paste, and I can run it. Then I can start messing with it, and that's how I learned. That just didn't exist. And it just made it extremely frustrating for me. And the documentation was difficult for me to understand because it was more of a functional specification. So I with the no online community and the documentation not, built the way that I like it, it was really difficult for me. And honestly, the OML notebooks, they were very unstable, which means they could just start spinning. And if I had not saved them, I would lose data, especially if I switch between like two notebooks, which you always have two notebooks, copy and you paste, and you're playing with stuff, you're learning and you're developing. It's not good. Okay, free tier, which is what I want to do this on. I think most people want to learn on free tier and experiment and stuff like that. It's incredibly slow, and the notebooks are even more unstable. And I think it's because the free tier is so locked down in terms of resources. The whole OML infrastructure takes a lot of memory and CPU to run. And I think it just blew the thing up every once in a while. I literally destroyed multiple autonomous databases, literally destroyed them. They would not, they wouldn't restart. If they did restart, I could not connect to them, even from SQL Developer. So it was easier just to get rid of them, terminate them, and actually restart them. So if you use a paid autonomous database, okay, it's quicker, and you're less likely to have stuff kind of just not work. But still, the notebooks were actually really unstable at the time. The jobs facility was awesome, made my deployment really easy. But I got a bill for $900 once month from Oracle. Try and negotiate that away. Not going to happen. So it was either because the job's running every 20 minutes, small, quick jobs, but with the notebooks, every 20 minutes, I got charged every hour of the day, or through the instability, there were just processes running that I got charged for. I don't know. But the lesson there is, if you use jobs, you better check your bill and see what's actually going on. Which means if I was to do this again, I would not use jobs. I would take all the code in the development, in the deployment notebook, and I would put that in the REST API. And so that gets run on demand. Boom. I tried to do that, but it wasn't real simple SQL in that notebook, and I just couldn't get it to work. If I was a PL SQL developer, I probably could have got it to work. Okay, so that was like kind of on me on that. But that's one thing I would do if I was to do this again. So in the end, it worked fantastic. I mean, everything, it's super stable. It just works every time I actually use this. So that's the good news. The bad news was it was a pretty hard experience for me. All right. So if you actually want to go through what I did, you can, I know the presentation will be online here, but I do have all the step-by-step stuff in the notebooks on the website. And here's the GitHub. So you can grab my data sets if you actually want to do that. Okay. Get trained, talk to my guys, have fun with Shane. Thank you guys for listening. Yeah, it's been great. It's my first time talking with you all too, so I appreciate that. All right, Roger. You're muted.
You did a fantastic job. Yeah, sorry, it was still delayed. You did a fantastic job. I enjoyed that immensely. I share your frustration with some of the free tier stuff, but that's I guess it's the old adage. You get what you pay for.
Yeah. Mm-hmm.
Mm-hmm. Preferably not $900 worth though. So, but thank you. There weren't any questions. Anybody who does have questions, please feel free to post them to us either on the Slack channel or send an email to Shallahamer. Sorry, I nearly got a perfect record at viscosityna.com. This will be posted up in the archive within the next week or so, and on YouTube. So thank you so much, Craig. Really appreciate you coming on.
My pleasure. Thanks for having me. Really,
right. Thanks, everybody. Bye-bye.